Welcome to the first episode of Atmn Aware. Today, we're really plunging into a fascinating area of AI. It's something that's rapidly changing how businesses, maybe like yours, can actually use large language models, LLMs, but without that massive, massive overhead we usually associate with them.
Yeah, we're talking about LLM distillation. So
Yeah.
our mission today, we want to unpack what LLM distillation really is, why it's becoming, frankly, crucial for your bottom line, and importantly, how it works, especially looking at all the different, sometimes quite clever methods being developed. We've pulled this together from, recent research papers, open source announcements, tech blogs from big players like RCAI, Google, NVIDIA, IBM, Stanford, quite a range.
Right. And this deep dive, it's really meant to be a shortcut for you. The goal is you walk away understanding how you can make this advanced AI much more accessible, more efficient, and really more impactful inside your own organization. We're kind of distilling the essence for you.
Okay, let's unpack that. LLM distillation, what are we actually talking about here? Is it like just making a big model smaller? Well, not quite that simple. Think of it maybe like a master chef, right?
Yeah.
Decades of experience, knows every complex technique. Now, they need to teach an apprentice. They won't just throw the giant cookbook at them.
Right.
Instead, the chef distills the core techniques, the essential flavors, into something manageable, something the apprentice can actually learn and use effectively. In AI, it's pretty similar. You've got this massive teacher model, incredibly powerful, knows a ton, but it demands huge computing power, lots of resources.
Okay.
The goal is to create a student model, much smaller, much leaner, but it captures most of the important knowledge from that teacher. And crucially, it can run efficiently maybe on a standard server, your laptop, even potentially a phone. It's like taking this, vast university library, all that knowledge, and condensing the core insights into a really sharp, concise executive summary that you can act on.
Okay, so that analogy makes sense, taking the core knowledge into something more manageable. But what does that mean for businesses practically? Why is this shift from the giant model to the nimble specialist? Why is that such a big deal?
That's a really important question. There's this idea, maybe going back to Jeffrey Hinton, that training and deployment have different needs. Like, think of an insect. It has a larva stage, just focused on gathering energy, right?
Yeah.
And an adult stage for travel, reproduction, different goals.
Interesting analogy.
Yeah, so for businesses, distillation lets you bridge that gap. It means, first off, AI for everyone. Smaller models make advanced AI accessible beyond just the big R&D labs. Think smaller departments, more employees using powerful tools.
Democratizing it in a way.
Exactly. Second big thing, saving energy and money. This is huge. Smaller models need way less compute power. They cut your operational costs, your server needs, your energy bill. It's like downsizing from a huge data center to something maybe pocket-sized, relatively speaking. The savings can be dramatic.
And I imagine that has environmental benefits too.
Absolutely. A lower energy footprint is a significant plus. Third, enhanced privacy and security. This is critical. If the model is small enough to run on your own devices or on-premise servers.
You don't need to send sensitive data out to the cloud.
Precisely. Your proprietary information stays closer to home, under your control. Big win for compliance and data security.
Okay, that's a major point.
Fourth, you get specialized AI assistance. Instead of one giant generalist LLM trying to do everything, you can distill models that are experts in specific areas relevant to your business. Legal document review, medical coding, technical support for your products.
Like using a specialized scalpel instead of a Swiss Army knife, as you said.
Exactly that. You wouldn't use a generic tool for a highly specialized task if you could avoid it. And finally, number 5, improved explainability. Smaller models are just inherently easier to understand, to interpret.
So you can see why the AI made a certain decision.
Right, which is absolutely vital in sensitive areas, finance, healthcare, anywhere you need to trust and verify the AI's reasoning. It's less of a black box.
Okay, the benefits are clear efficiency, cost, privacy, specialization, explainability. That's compelling. But now the how. How does this knowledge transfer actually happen? You said it's not just shrinking.
Correct. It's about smart knowledge transfer. And knowledge here isn't just, the model weights or parameters. It's really about how the model generalizes, how it applies what it knows to new situations it hasn't seen before. There are several really interesting ways to do this.
All right, let's get into those methods.
Okay, the first main category is response-based knowledge. This is often called logit distillation.
Logits,
Yeah.
right. So the idea here is the teacher doesn't just give the student the single right answer.
Exactly. It shares its entire thought process in a way. It gives the student the probabilities it assigned to all possible answers, not just the top one. These are the soft targets.
So if it thinks an image is 99% a fox, it might also say, well, there's a 0.9% chance it's a dog and like 0.001% it's a sandwich.
Precisely. That tiny 0.9% for dog is valuable information for the student. It's like the teacher saying, look, it's almost certainly a fox, but hey, it does have some dog-like features you should be aware of. It's that nuance, sometimes called dark knowledge.
Okay, I see. That adds context.
And we can control how soft or spread out these probabilities are using something called the temperature parameter during distillation. Higher temperature smooths out the probabilities, makes the less likely options more visible.
Like turning up the brightness to see subtle details.
Good way to put it. It helps the student learn those nuances. And there's a newer approach here, too, called universal logic distillation, or ULD loss. It uses something called Wasserstein distance.
Okay, Wasserstein distance sounds complex. What's the practical takeaway for, say, a business user?
Right, let's simplify. Older methods sometimes just tried to match the student's output probability for each word directly to the teacher's. ULD loss, using this distance measure, it's more sophisticated. It looks at the overall shape of the probability distribution.
The whole picture, not just individual points.
Exactly. It ensures the student learns the rich relationships between potential words, not just the single most likely one. This is especially important for generating text, making sure the student model produces more natural, coherent language, capturing the teacher's style and knowledge more deeply, often even with less training data needed for the distillation itself. It helps avoid just mimicking the most frequent answers.
Got it. Better quality generation, potentially more efficient transfer. Okay, what's the next method?
The second type is feature-based knowledge. This is about learning from the teacher's intermediate steps.
So looking inside the teacher model's process.
Exactly. We extract information from the hidden layers of the teacher's neural network. These layers represent how the model is extracting features and building up its understanding. Think of it like a seasoned detective, showing a rookie not just the final conclusion, but how they piece together the clues along the way.
So early layers might spot broad patterns, deeper layers get more specific.
Precisely. Maybe an early layer identifies animal, a middle layer identifies canine features, and a later layer concludes fox. Transferring these intermediate representations helps the student build a similarly robust internal understanding, not just memorize the input-output mapping. It helps it generalize better.
That makes sense. It's about learning the how, not just the what. Okay, and the third type you mentioned.
That's relation-based knowledge. Here, the focus shifts. It's not just about individual inputs or features, but about the relationships between different data samples as understood by the teacher.
Okay, how does that work? Like how data points connect?
Yeah. Imagine teaching a student about history. You don't just give them isolated facts. You teach them how events influenced each other, the cause-and-effect relationships. This method transfers how the teacher model sees similarities or differences between inputs.
So it learns this customer review is similar in sentiment to that one, even if the words are different.
That's a great example. Or this pattern of network traffic often precedes that type of security alert. Transferring these relational insights gives the student a deeper, more contextual understanding of the data landscape. Very useful for things like recommendations or anomaly detection.
Fascinating. So we have response-based, feature-based, and relation-based knowledge transfer, but you also mentioned different ways to actually run the distillation process itself.
Absolutely. The strategy often depends on your situation. There are three main modes. First, offline distillation. It's one of the most common. The teacher model is already fully trained. Its knowledge is fixed. Its weights are frozen. The student learns entirely from this pre-existing static mentor.
So you have a big trained model ready to go and you just distill from it.
Exactly. Often used if you're using a large, maybe proprietary foundation model as your teacher. Second, online distillation. Here, things are more dynamic. The teacher and the student models are trained together, learning and adapting simultaneously.
Like they're training partners.
Yeah, like partners pushing each other. The teacher might also be learning or fine-tuning during the process. This can be useful if you don't have a perfect pre-trained teacher, or if you want the teacher to adapt too. And third, a really interesting one, self-distillation. This is technically a form of online distillation, but the twist is the teacher and student are the same network architecture.
Wait, the same model teaches itself? How?
It sounds odd, right? But the idea is often that deeper, more complex layers of the network teach the shallower, simpler layers within the same model, or the model at a later training stage teaches itself at an earlier stage.
Huh. Like mentoring your younger self.
Kind of. And what's really interesting is that some research suggests the main benefit here might not even be transferring complex dark knowledge, but rather the process acts like a denoising mechanism. It helps clarify the training signals, making the learning process more robust and effective for the final model. Less about secret insights, more about refining the core message.
Okay, that's counterintuitive but interesting. And I know businesses are always looking for maximum efficiency. How does combining distillation with other techniques, like, say, pruning, fit in?
Ah, yes, that's a very powerful combination. Pruning is like literally trimming the fat from the model. You might remove entire layers, that's depth pruning, or cut out less important connections or neurons within layers with pruning.
Making the model structurally smaller first.
Right. But pruning alone can sometimes hurt accuracy. That's where distillation comes back in. You take the pruned, smaller network and then use distillation to retrain it using a larger model, maybe the original unpruned one, as the teacher.
So prune first, then distill to recover or even boost performance.
Exactly. This often helps a smaller pruned model regain accuracy, sometimes even exceeding the original performance while being significantly smaller and faster. It's a highly cost-effective strategy. Think of sculpting. You roughly carve away the excess stone first, pruning, then you meticulously refine and polish the details, distillation.
That makes a lot of sense from a resource perspective. We also saw mentions of even more specific techniques in the sources, something about combined multitask loss and context distillation.
Yes, those show the flexibility here. The distilling step-by-step approach, for example, uses techniques like combined loss to train a smaller model to not only give an answer, but also generate a rationale explaining its reasoning.
So the small model can explain itself, potentially even better than the big one.
Sometimes, yes,
Right.
which is huge for trust and usability. And then there's reverse KLD, used in methods like LLM. This is really clever. It tries to prevent the student from overfitting to the teacher's potential noise or minor inaccuracies.
How does it do that?
It focuses the student on learning the most important, high-probability information from the teacher, essentially ignoring the less certain parts. It's about capturing the core truth, not mimicking every single subtle, possibly incorrect inflection of the teacher. This leads to more accurate and truthful generations from the smaller model.
Focusing on the signal, not the noise. Okay. This is all great in theory, but let's talk brass tacks. How is this actually playing out for businesses now? Are there concrete examples we can look at?
Oh, absolutely. The impact is very real and happening right now. We're seeing distillation delivering tangible business value. For instance, look at RCAI's Distill Kit. It's an open source toolkit designed precisely to help businesses create these powerful, specialized small language models, SLMs. They demonstrated distilling a 7 billion parameter teacher down to a 1.5 billion parameter student, a significant size reduction, making it much more deployable.
So tools are emerging to make this easier.
Definitely. Then you have NVIDIA's Llama 3.1 Minitron 4B. This is that pruning plus distillation combo we talked about. They took an 8 billion parameter Llama model, pruned, and distilled it down to 4 billion parameters.
Half the size. What was the performance trade-off?
That's the kicker. They achieved 1.8 to 2.7 times faster processing speed or throughput while keeping performance highly competitive. Imagine doubling your AI speed while cutting compute needs roughly in half. That's a massive win for operational efficiency and cost.
Wow. Okay. Faster and cheaper.
Then there's Stanford's Alpaca 7B. This was a really interesting academic project, but with huge business implications. They fine-tuned a Llama 7B model using distillation from a much larger model, like OpenAI's Text DaVinci 003. The cost, less than $600. The time, just 3 hours on a few GPUs.
$600 in 3 hours.
Yep. And the resulting 7B model showed instruction-following capabilities qualitatively similar to the giant OpenAI model it learned from. It proves you can achieve very high performance incredibly cost-effectively, like building that high-performance sports car on a budget sedan's budget.
That really lowers the barrier to entry.
Hugely. And finally, think about models like TinyBERT and MobileBERT. These were earlier examples focused on making the powerful BERT model usable on edge devices. TinyBERT is like 7.5 times smaller, over 9 times faster than its teacher. MobileBERT, similarly smaller and faster than BERT-base. These aren't small tweaks. They're transformative changes enabling AI in totally new places.
So bringing this all together then, for the business leaders listening, navigating this, sometimes overwhelming AI landscape, what's the main takeaway here?
I think the key message is this. The cutting edge of AI isn't just about building bigger and bigger models anymore. It's increasingly about making AI smarter, leaner, more efficient, and adaptable to your specific business needs. Distillation is a core strategic tool for that. It provides a practical path to deploy powerful, custom AI solutions that are cost-effective, use less energy, and respect data privacy. It lets your business move faster, innovate more effectively, and gain a real edge without being crippled by the resource demands of giant models.
Yeah.
It's really about getting that golden nugget of AI insight without having to, mine the entire mountain to find it.
To understand how your business can benefit from LLM distillation, just go to atmnai.com today and schedule a call with an Atmn AI expert. See you next time.